Dear students, let us begin the third part of the lesson, in which you will learn about the testing goodness of fit of the proposed probability distribution and regression model. The chi-square test assesses the goodness of fit between observed and expected frequencies based on a probability distribution. The steps involved in conducting a chi-square goodness of fit are as follows. Collect the data and calculate the observed frequencies for each category. Fix the level of significance. Then, in computing these goodness of fit, you have to move on with different probability distributions, as earlier we have discussed. It may be in a discrete, it may be in a continuous. When you are moving towards the probability distributions, you have to be concentrated on what type of distribution you are using, either discrete or continuous, and you have to choose related probability mass function or probability density function. With that, you can calculate your expected frequency properly. Now, determine the number of expected frequencies for each category or range based on the proposed probability distribution or regression model. Earlier in probability distribution, you are concentrated on discrete or continuous, whereas here in a regression model, you have to be clear about what type of model you have been chosen and how you have been fitted the equation. The parameters of the model will play a major role in comparing your observed and expected frequency. Collect data and calculate the observed frequencies for each category. Then calculate the test statistic, chi-square statistic, by comparing the observed and expected frequencies. Here you have been calculating the expected frequencies through the probability distribution or through the regression model, but you need to go for the comparison with respect to them based on chi-square statistic. Then determine the degrees of freedom for the test, as you know that the calculation of degrees of freedom will be varied in chi-square based on the problem. Whereas if you go for the simpler one, where you can go with an number of observations minus 1, whereas if you go for the category base, that is the attributes, in a contingency table you can go with number of rows minus 1 into number of columns minus 1. You have to be clear about that. Determine the critical value or the p-value associated with the desired level of significance. In a further lessons, you can also know about how you can get your critical value chi-square from a table sheet, whereas the p-value is obtained from the software, where I mentioned in the previous lessons that when you are having the data set in a larger fashion, where you have to move for the software, where you cannot move with your manual, then while calculating through the softwares like SPSS or Python, whatever may be the software, you will be getting p-value. With that p-value, you have to go for your decision. Compare the test statistic to your critical value and decide on the null hypothesis. You know that the test statistic calculated value and critical value can be compared and you can go for your decision. Whereas if you are having a p-value, that is if you are going for software based, then your p-value has to be compared with your alpha value. If your test statistic is greater than or equal to the critical value, then you can reject your H0, indicating that the observed frequencies do not fit the proposed probability distribution or regression model. Suppose the test statistic is smaller than the critical value, then you can accept the H0, suggesting that the observed frequencies are consistent with the proposed probability distribution or regression model. Here, while concluding, for probability distribution, you can use the word as fitting of probability distribution. That is that you can say that it is not suitably fitted or this is suitably fitted. You can use those words. Whereas in a regression model, you can use the same thing as the fitted model is properly fitted, or you can say that which helps the values in a proper way. Whereas in your p-value, you can decide about your significance, whether I am going for insignificant or significant. You can fix your null hypothesis H0, as there is no significant difference between observed and expected frequency. and in H1 there is a significant difference between observed and expected frequency. That is your alternative hypothesis. As I mentioned, you have to go for your null hypothesis and alternative hypothesis while taking the statement. If it is a generalized one, you can leave as it is, but if you go for a peculiar problem, then it has to be problem oriented, that you can see in the further lessons. Now coming to the example, a survey of 240 families with 4 children each revealed the following distribution. Here you can see the table: male births as 43210 and observed frequency as 10, 55, 105, 58 and 12. So here the data represents that 240 families are having 4 children. Among them there is no male, that is 0 male children is 12 families, whereas here you can see that 58 families are having only 1 male children, whereas 105 families are having 2 male children. Similarly 55 families are having 3 male children. At the end 10 families are having 4 male children, that is the 4 children are male. You can see the probability distribution, how it has been distributed. Here the data follows binomial distribution with the parameters holding n as 4 and p as 0.5, where p is your probability of success. It has been divided as equally 0.5. We can obtain the probability by substituting the number of male births 0, 1, 2, 3, 4 in the probability mass function of binomial distribution. Then by multiplying each probability with the total frequency, that is 240, we can obtain the expected frequencies. The probability mass function of a binomial distribution is given as p of x equal to x, ncx, p to the power of x, q to the power of n minus x, where your x takes the values from 0, 1, 2 and so on n, 0 otherwise. As I mentioned here, your values will have only positive integers including 0. If you have been getting any negative value or any other decimal, it will be considered as 0 defaultly, where your probability function ncx p to the power of x n minus x here, which will speaks about the combinations. Earlier I have been spoke an example on tossing a coin. Here n will speaks about that number of times you are conducting the experiment, among that x number of success you are expecting, whereas your p represents probability of success, q represent probability of failure. You can calculate the expected frequency by multiplying the values of the probability obtained here with your frequency, that is you can get values as male births in 4, 3, 2, 1, 0, whereas in observed frequencies it will be 15, 60, 90, 60 and 15. By applying the chi-square test to the observed and expected frequency of the data, we decide on the acceptance of hypothesis, whether you are going to accept or whether you are going to reject the hypothesis. Dear students, we come to the end of our lesson. In this lesson, we went with the 3 different parts. In the part 1, we went with the discussion of one-way frequency table, how to create and how to calculate the expected frequencies with an example. Then in part 2, we went with the computation of expected frequencies in probability distributions as in discrete and continuous. Then at the end, part 3 we have went with the procedure for testing of hypothesis and a computation of expected frequency in distribution. I am confident that you understood all the concepts which we have covered in this lesson. We have completed our lesson on calculation of the chi-square, goodness of fit test and one-way classification. Thank you.